Okay, so in this next video, we're going to describe a couple of the key ideas of object-oriented programming. There are actually four things that almost every textbook on object-oriented programming mention: encapsulation, abstraction, inheritance, and polymorphism. And these are often held up as kind of the four key pillars of OOP. These ideas are all make the most sense when you see examples of how they really work. And since inheritance and polymorphism, we're not really ready yet to talk about those, I'm just going to talk about encapsulation and abstraction today. So encapsulation is an idea I've already mentioned in the previous week's videos. And this is one of the essential ideas of object-oriented programming, that through encapsulation inside of an object, we can group code and data together. And this is important because it makes coding easier. If you have an object, then that means not only do you have its data, but you also know what operations you can do on that object. And putting those together in kind of a unit makes it easier to understand what you can do with code, as opposed to an object, its data and code being separate things that are managed separately, and you don't know how to put them together. And abstraction is defined as hiding the details of an implementation and exposing only the essential information. Abstraction is a word that sometimes people toss around with a lot of abstraction. Sorry, that's a recursive definition. I used the word in the definition. But abstraction really just means hiding details, right? Being able to talk about something in a general way, without getting stuck into all of the tedious information of how it works, right? So what abstraction means for us is that we don't have to know or worry about all the hidden details of how an object works to use it. We just get the object, we understand the functions it supports, and we call those functions, and then we fully expect the object to do the right thing and to work in the right way. Of course, anyone who's used software knows that doesn't always pan out, but that's the key idea of abstraction. And when we're using objects and when we're making our own objects, we really want them to have good abstractions. We want them to hide the right information and expose the right information to us. Right, so when we make our own objects, we want to encapsulate the important data and functionality within the object, and we want to hide details that an object's user doesn't need to know. So these are two key takeaway points that are important as we start making our own objects. Okay, so let's consider an object that implements a complex number. We know that a complex number has a real and imaginary part. And we also know that they are defined over operations like addition, subtraction, division, multiplication, maybe others. Also, there are multiple ways you could implement them. You could implement it in polar form or rectangular notation, and either implementation would be fine. Okay, so an example of abstraction would be hiding the details of how a complex number is actually implemented. For example, I could use option one, where I implement the complex number with two doubles that represents the real and imaginary part in rectangular form. Or I could use option two that implements a complex number with two double values, one that represents the magnitude and one that represents the angle. And by making these doubles private in both of these classes, what it means is that anyone using the object doesn't need to understand that implementation choice. It's hidden from the user, and so they can just focus on the other details of using the object. So because these are private, we are hiding the implementation. And one thing I will point out that you might notice is that for my implementation in polar form, my constructor here is still taking a real and a rectangular format complex number. And so that's all, my abstraction is a little bit broken there, but that's okay. I mean, how you implement something inside, it's irrelevant how you initialize it, as long as as long as the user understands how to initialize it. So we could choose either one of these implementations and hide our choice, and then by hiding that choice, we're free to implement the rest of the object however we want. Okay, then encapsulation means that we're going to embed all the extra arithmetic operators into the class so that somebody who has a complex number knows the operations they can perform on it. Like, for example, we know you should be able to add a complex number, subtract, multiply, divide. And so like maybe what this add function means is that we're going to add the complex number we pass as an argument into this object that we're applying it to. And so like the real and imaginary components of this C would get added to the real and imaginary components of the object. Same with subtract. I could subtract the complex number I pass in as an argument from the object we're subtracting it from, right? And multiply and divide could be implemented in similar ways. To kind of make this more concrete, let's look at add. So I pass in the variable C into the add function, and then we add to this object's real part, the real part from the C object, and then we add to its imaginary part, the imaginary part of the C object. Okay, now this same object description applies to both C and the object we're running it on, right? So like to make this clear what's happening, I might declare a complex number J and a complex number X. And then I can add J to X by saying X dot add and passing J in parentheses. And now what's going to happen is that J has 1 for its imaginary value and 0 for its real. And X has 1 for its real and 0 for its imaginary. And when I add J to X, what's going to end up happening is that X will now have 1 for its real part and 1 for its imaginary part. Right? We don't, from just this code, all I'm seeing is I have a couple of complex numbers and I added J to X, and I don't really need to worry about how they're implemented because that implementation is hidden from me in these private variables. And I know that this add operation is provided on the object, so I have high confidence that it works, you know, based on encapsulation. Okay, so in summary, we've covered some of the key ideas of object-oriented programming. Encapsulation is just this idea of grouping code and data together, and that's provided for us by classes in C++. And abstraction is hiding non-essential details. And so far, we've seen how this is provided by access modifiers like public and private. We're going to continue to build on these ideas, embellish them as we learn more features of C++, which is why I called this video part 1. There'll definitely be a part 2, and there may be more than that. Thanks.